Hi there, it's Ruth, and today we'll be converting a few improper fractions to mixed numbers. And improper fractions are fractions where we have the numerator being greater than or equal to the denominator. So with the first fraction, 13 over 4, 13 is a numerator and that's greater than the denominator of 4. So that's what makes this fraction an improper fraction. And we're going to be converting these to mixed numbers. These are numbers with a whole number and a fraction component. Basically, we want to see how many times can we get the denominator from the numerator. And we're going to be dividing so as to help us with these conversions. So we'll set up our 13 divided by 4. How many times does 4 go into 13? 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. So 3 times. It goes in 3 times. 3 times 4, 12. 13 minus 12 is 1. So that will be our remainder, 1. Now this setup here is going to assist us with deriving the improper fraction. The whole number component is how many times do we get the denominator from the numerator, and that's right here 3, because we know that we get 4 3 times from 13. 3. The denominator remains unchanged, still 4, and the remainder is the new numerator. So 13 over 4, represented as a mixed number, is 3 1/4. All right, we'll move to the next example, 19 over 3. Again, we want to know how many times can we get 3 from 19. So we're going to set up our division. 3 times 1, 3, 3 times 2, 6, 3 times 3, 9, and so on. We know that 3 times 6 is 18. 6 times 3, 18. 19 minus 18, again, 1 will be the remainder. The whole number component of the mixed number is the number of times we can get the denominator from the numerator. So that will be here 6. Again, the denominator remains unchanged, so it will still be 3. And the remainder is the new numerator. So 19 over 3, represented as a mixed number, is 6 1/3. All right. Third example, 34 over 6. How many times can we get 6 from 34? We know that 6 times 1 is 6, 6 times 2 is 12, 6 times 5, 30. Right before the 6. So 5 times 6, 30. 34 minus 30, that leaves a remainder of 4. The whole number component, how many times can we get the denominator from the numerator? And we're told that here, 5 times. The denominator remains unchanged, and the remainder is the new numerator. And this fraction we could simplify it if needs be. All right, 48 over 5. We want to see how many times can we get 5 from 48. We know that 5 times 9 is 45. 5 times 10 is 50. If we did 50, we'll be going over. So we're going to say 9 times. 9 times 5, 45. 48 minus 45, 3. 3 remains. All right. So again, this setup assists us with deriving our mixed number. The whole number component is how many times do we get the denominator from the numerator. That's 9 times. The denominator remains unchanged, which is 5, and the remainder becomes the new numerator. And with this fraction here, we could, simplify by dividing both the numerator and the denominator by 2. So that actually becomes 5 2/3. or 5 and 4, 6. All right. So we have the steps here. Divide the numerator by the denominator, because essentially we want to know how many times can we get the denominator from the numerator. The whole number component will be this number, as in how many times did we get the denominator from the numerator. The remainder will be the new numerator for the mixed number, and the denominator will stay the same. Thank you. And parents, if you have additional questions, please feel free to leave them in the comments below. Thank you.